In this lesson, we're going to be talking about virtual LANs, or VLANs. Sometimes they're called VLANs for short. What's a VLAN? Well, a local area network is a set of physical networking devices and cables. The reason we have virtual local area networks is because sometimes you want to set up different physical networks without actually deploying the physical hardware like switches that would allow you to do that. So you want to have some sort of physical isolation between different network segments, but you don't want to have to go purchase expensive switches to be able to do that. So you have one larger switch that you can connect a number of computers into, and it allows you to set up different ports in the switch so that different computers can be on different virtual local area networks. So how do we go about doing this virtual local area networking, or VLANing? I've got a packet capture here, and you can see there's a number of packets or frames that have been captured. Right here, we've got the Ethernet header. This is the layer 2 header in the packet. So I've got my Ethernet header here, and here's what you would typically see. You would typically see the destination MAC address, the source MAC address, and then you would have the type. And in this case, I've got an IP packet. Additionally, we've got some other headers in this packet here. So we've got a VLAN tag. And this VLAN tag right here says VLAN equals 118. Now 118 is the number of the VLAN. So I can have a wide range of numbers which allow me to give some identification to the different virtual networks that I have. So I could say people in marketing are on VLAN 100. People in human resources are on VLAN 110. People in development are on VLAN 120, and so on. So I've got VLAN 118 here. This is what we call an 802.1Q tag. So 802.1Q is the protocol specification for this VLAN tagging that allows the packets to be flagged as being part of a particular VLAN. So you can see here I've got this 802.1Q tag, and when a switch sees that tag, it says, oh, you belong to this particular network, and it knows which ports in the switch fabric are part of that particular virtual LAN. And so broadcast messages would only go out to those particular ports. Unicast messages, of course, are going to go to the specific port that the system that owns that address is connected to. This 802.1Q tagging that we've got gives us the ability for PCs to join these local area networks, or in some cases be on multiple networks at the same time, depending on what the switch configuration is. But certainly switch-to-switch communications have this 802.1Q tag here that gives us the ability to flag particular packets as being part of one VLAN or another VLAN. So again, 802.1Q and virtual LANs, or VLANs, give us the ability to set up multiple networks which would otherwise be physical networks, but it allows us to create logical networks from the same physical networking infrastructure, and all of the partitioning is done inside the network hardware itself. We don't have to worry about having multiple switches because the switch does all of that isolation and partitioning and makes sure that the traffic for particular VLANs stays within the right ports that belong to those particular VLANs and doesn't go outside of them. So we get that separation, and it's all done inside the switches.